Hi, Sean McElroy here, back with our Autoline exclusives. Today I'm talking with Thomas Parker. He is the automotive market sales manager for North America for a company called INFICON. And we're talking with them today because we want to talk all about leak detection. Some of our normal viewers have heard me talk about this before, so they might have a little bit of an idea. But we're actually going into some interesting new technology in the field. But before we get to that, kind of what is leak detection? I think a lot of people have a slight idea just based on the name. A lot of the times it's associated with taking a wheel and tire or gas tank and dunking it in a big tank of water and looking for bubbles. And, you know, obviously, Thomas, while that is leak detection, the stuff we're talking about is a little more sophisticated than that. Can you give our viewers a little bit better of an idea what leak detection is?
Sure, Sean. And you bring up a great illustration that we can all relate to. You put a bicycle tire underwater, you look for bubbles, you patch it, you're back on the road. The sophistication comes in on the size leak we're looking for. If you equate it to bubbles underwater, some of these leaks that you're looking for example, in an air conditioning circuit, may take 30 minutes to form a bubble. Um, Things like airbag inflators or pacemakers, things that get leak tested on that level, they would never form a bubble in years. So we're looking at the sensitivity, the size leak that you can find, and we're also looking at the certainty that you can see it. If you're fixing one bicycle tire and that's your bicycle tire, you're pretty invested in finding that leak, and you're going to rotate that tire, and you're not going to stop until you find the leak. The measurement certainty comes in on the liability side. Are we certain that this product is leak free? And you mentioned gas tanks. That's something that INFICON does a very big business with, not just gas tanks, but the whole fuel system, fuel pump, fuel injectors, fuel rails. All that gets leak tested to very low levels, and they require very high measurement certainty, because if you have a leak in the fuel system, you certainly could have a disaster.
For sure. And you kind of touch on something great there, is that we're not talking about just one system here. We're talking about so many different things. And the one of the big things in the auto industry right now is EVs. And what we're here to talk about today is you guys have got some great new technology in leak detecting lithium-ion battery cells. Why don't you just kind of jump in and, talk about the new tech that you guys have developed?
Yeah, well, let me start from the beginning. The beginning was the needs of the customer need. For probably 5 or 7 years globally, INFICON has been participating in leak testing battery packs and rigid battery cell housings. So when I talk about the individual cell housing, battery packs may have hundreds, if not a couple thousand cells inside the huge pack. So for many years, we've been leak testing the pack, the cell structure itself, and using helium, our customers would leak test the rigid cell construction, the laser welding, the anode and cathode feed-throughs, and they would get it all buttoned up, leak tight, with the exception of one fill port where they would fill the electrolyte into. And the need of the customer was, INFICON, we're fairly certain that this thing doesn't leak, but we've put electrolyte in it. Now we still have to seal this final hole, the fill hole. How can we detect electrolyte directly? So that's what started in motion about 3 years ago, the development for this new product, this ELT 3000, that is catered to detect the electrolyte itself in the rigid and also soft pouch battery cell form factors.
So very cool. We're not talking about just one type of construction type with a battery. I think I read right, you could do cylindrical, prismatic, and pouch, which is great. And even on top of that, different battery chemistries in terms of the electrolyte. There are a number of different types of electrolytes that you could test for as well, a lot of the common ones.
Exactly. You're correct on all fronts. All the form factors, rigid and soft, as well as all electrolyte chemistries.
And so do I have this right? Uh, Before, when we were leak testing, like kind of the current way of doing it, you couldn't really test a battery cell with the electrolyte in it. Do I have that right?
That's a correct statement. The customers would do a helium leak test of the rigid construction cell. Um, there was no possible way to do an electrolyte test before this product development. Now, for the pouch cells, if you've ever seen a pouch cell, they're kind of flat and they're under pressure, which means a vacuum is applied to kind of shrink it to itself, vacuum formed, if you will. The leak testing of that was literally a visual test. If the pouch swells, they knew that water ingressed, created a reaction, and swelled the pouch. So that would be a visual test that was done for the pouch cells. And for the rigid cells, they would just hope that that fill port got sealed properly.
So when you're talking about helium, are we talking about taking the actual cell and filling it with helium and trying to use a machine that can detect that helium, and then it goes, oh, hey, I'm detecting something here, I know there's a leak? Is that basically what it's doing?
That is exactly what it's doing. So on the rigid cell construction, the customers would charge the rigid prismatic cell with helium, put it in a vacuum chamber with a sampling device looking for helium, and that would be a go, no go. And that's of the individual cell. Now, with the entire battery pack, and some of these battery packs are the size of a king size mattress, our customers are actually charging a low pressure helium in the battery pack, and we're using robotic sniffing to leak test the seams, the tray and the lid connection, the electrical feed through. So helium is used extensively in the cell construction as well as the battery pack construction.
So how does this new technology, I understand you guys are using something based on a mass spectrometer. How is it different than what had been used currently previously?
The mass spectrometer that we're using is not that much different as far as the principles of operation. Now, what is different is how we deliver the gas sample, because what we found is electrolyte has certain viscosity and volatility properties that make it tough to sample at atmospheric pressures. So the real development was taking our already robust quadrupole mass spectrometer and outfitting a system that could, at the correct pressures and under the correct conditions, deliver a sample to be analyzed. Sean, the other long development was the calibrated leak to give metrology. That was probably the bigger challenge of the development, because we developed a calibrated leak with the electrolyte material inside it. And that was challenging because if you look at, again, the properties, viscosity, and vapor pressure of the electrolyte, it will clog leaks unreliably. That means that the leak will be open and then the leak will clog. The leak will be open, the leak will clog. And for calibrated leaks, for metrology, for benchmarking, for quality audits, you want a consistent signal. You want something that's consistent day to day that you can use to challenge a machine or get a quality audit done. And coming up with a calibrated leak based on electrolyte, that was pretty challenging. So the mass spectrometer that we have has been around for many years. You may see them in refrigerator plants, freezer plants. They're kind of the industry standard for refrigerant leak detection, end of line automotive assembly for AC systems. So we took something robust and well known, but we had to create a system around it to give the exact pressures, the exact sample condition, and we had to meet the challenges of that calibrated leak so our customers could have metrology behind what they're measuring.
So I know this is very basic, and it's really kind of just to help myself wrap my head around this. When we talk about mass spectrometers, and I was kind of looking into it a little bit, is this the same kind of thing that we sometimes see like on crime shows, where it gives like a little graph with a large line up and says, oh, we've got a large concentration of this element here, or maybe we've got some fine particulates of this there. Do you get the same kind of readouts, or or have I jumped a little too much there?
What you're seeing on crime shows, they're probably gas chromatographs. Mass spectrometers are typically used in industry and some analytics. I'm not saying that there's not a crime lab out there somewhere that would have a mass spectrometer component of a gas chromatograph, but What this does literally on the molecular level is it separates out molecules. So we're looking at mass peaks. So you mentioned some sort of graph with an outline. Behind the scenes, you could see that happening. If you've got different masses of molecules, like you've got different electrolyte solvents, you've got different mass structures, when you ionize that stuff and you accelerate it so you can filter it, that's what you're literally looking for, are the mass peaks of what you're separating out once you ionize it. So in some ways, yeah, you do have a graph, you do have an overlay, and we've got a software interface that makes that nice for the customer, but probably not found on a crime show.
Well, all right, maybe bad example on my part, but what it comes down to is that you are getting reliable results every time you're doing this. That's, I believe, what this comes down to.
Exactly. I used the example earlier on in our discussion of pacemakers and airbag inflators. These are life safety critical devices that get helium leak tested. And our helium mass spectrometer is looking for one mass, that's mass 4 for helium. And you want to do that reliably every 9 seconds, because airbag inflators come off the production line once every 9 seconds and they operate 24/7. And if you misjudge that mass 4, that tiny amount of helium, then you could miss a leak. And if you miss a leak in an airbag inflator, you could have water ingress. And that's what happened with the airbag company a few years ago. They had leaks in their containers, and humidity, water vapor ingressed in and created a super high charge reaction that resulted in fatality. So if you miss a leak in this business, somebody could lose a life.
Well, that's a great point. And, when we're talking especially about EVs, sometimes they get a bad rap for vehicle fires. I know it clearly happens with gasoline-powered vehicles as well. Something like 200,000 vehicles annually in the US catch fire. But I think it's such a new technology that people are more focused in on it. And we've seen a number of reports of battery fires recently. And I think another good application for this would be there's even talks of integrating the battery right into the structure of the vehicle, which is obviously going to make any sort of service much more difficult. So you want to know that those cells are super tight. And I've got to imagine, making sure that a cell is properly sealed is going to increase the life of a battery over time.
Exactly. Right now, there's tons of information on the internet. You could go out and see a hybrid SUV that was launching a boat, parking brake came off, and the hybrid SUV floated around the lake for a little bit. Fire department pulled it out of the lake, and it spontaneously caught on fire. So you've got water ingress of the battery pack. You've got water ingress to the individual cell. And again, there could be hundreds, if not a couple thousand of these tiny battery cells. If you lose one, sometimes you lose the one next to it, and then you get some thermal runaway. So the drive here is consumer satisfaction. If consumers are seeing and hearing about battery fires, they're going to be less hesitant to invest in not just 100% EV, but even hybrid technology, where you have an internal combustion engine and some sort of lithium-ion battery pack. And Sean, you hit a great point. With automakers looking at making the battery pack into the frame of the car, that further exposes the battery pack to flooded streets, heavy rain, splash up. So that's where automakers are making sure that these battery packs are properly tested and actually rated against ingress protection, commonly called IP67, which is a water ingress limit that guarantees you won't have any water ingress if a pack is submerged at a certain depth for a certain amount of time.
So let's say I'm an automaker or a battery maker, and I want to adopt this new process. Do I need to purchase new hardware? What would I have to do to bring this system into my fold?
Yeah, what we're seeing is, obviously, along with the purchase of the system, customers are looking at automation. So maybe they've got robotic handling of the battery cells to load and unload the battery cell to the chamber. We're already working with several tier suppliers on factory lines that already incorporate this technology. So if somebody was already making cells, they would have to make room for this in their process. We are working with a lot of different customers on projects where this will be from a grassroots installation.
Oh, so there is some automation that can be formed into this process. You don't necessarily need humans loading everything in or running the tests and everything.
Exactly. It's very common. You mentioned gas tanks. I'm actually visiting a gas tank manufacturer tomorrow. And if you went there with me, you would see robots moving these huge plastic blow molded gas tanks from one operation to the next.
So in terms of battery cell testing, are you testing in batches? How long does it take to do a test? I'm kind of curious about that.
That's customer dependent. You could certainly do batches. So you make a chamber a certain size. It could hold either 1 or 10 battery cells. Again, depending on customer throughput, depending on their first pass yield. So if their yield is such that they could test 10 at a time and pass, great. But if they test 10 at a time and fail, then they have to split the batch so they can whittle down which cell is leaking. So you test 10, you fail them. Now you have to test 5 and then test the other 5. And you have to kind of narrow down which one. So we've got people doing individual cell consideration. We've also got people doing batch testing, again, depending on how certain it is that they think they've got a good yield.
And are there any quality standard requirements in the testing of battery cells right now that you're aware of?
That's a good discussion point. INFICON submitted a white paper that was accepted and released by the Society of Automotive Engineers, SAE, a few months ago. And we wrote this white paper on pushing that topic of let's get some hard and fast specs and standards on these applications. Right now, if you look at airbag inflators and if you look at fuel systems, those are the only common parts of the car that have a hard and fast spec behind them. A lot of other things are to the discretion of the automaker or the tier supplier. So we'd like to see the same industry specifications applied to battery components as fuel components and airbag safety components.
Do you feel this new technology could lead to an industry-wide standard then?
I think it'll lead to, I think it will, because first you have to have an awareness that, first you have to recognize, do I have a problem? And then once you recognize if you have a problem, you have to be aware of what tools are out there to help you identify the problem, quantify the problem. So I think this tool is going to help automakers put some numbers behind maybe some guesswork that was going on, just like the pouch cell technology being a visual inspection. Is the pouch ballooned up or is it still tight? That's the test that they look at it after a couple days. So I think this product will.
So are there any benefits that we might have missed here? I know we talked a bit about safety and, kind of customer awareness and easing their mind a little bit. Anything else that we might have missed here?
No, I mean, if you look at the integrity of the battery cell, you want to keep the electrolyte in, but you want to keep the water vapor out, because if the water vapor gets in, it creates a reaction. This exothermic creates heat, thermal runaway, could lead to fires. And it also damages the cell, obviously. So I think you've got customer safety. I think you've got customer confidence in the battery technology itself. Markets moving like the EV market, it's all about customer acceptance. Does this meet the customer demands? You've got range anxiety. You've got anxiety of, does the battery have a warranty? Am I going to have to replace this expensive component every 10 years? So I think we've covered all the bases there. It's really consumer satisfaction. Is this battery cell and the pack itself, made with the best quality and the best measurement certainty possible?
Yeah, and we've talked about it quite a bit here, but one of the major things of leak detection is safety. And now that we've kind of, I think, wrapped up a little bit on the battery cell side, there's another leak detection thing that you and I have talked about in the past that I think is also really important. And that's with like LiDAR systems and other autonomous systems. Can you just talk a little bit about why, something like that is really important, leak detecting even a camera itself or like a camera lens?
Sure. Sean, that's a great question. I was actually in Florida a few weeks ago working with a LiDAR company in Florida that's a customer. And earlier I mentioned water ingress protection levels, IP67, and that's a water ingress protection rating. And this customer is building these LiDAR assemblies with INFICON equipment testing to make sure that that LiDAR enclosure is not just watertight, but vapor tight. Because if you think about something being watertight versus something being vapor tight, if vapor creeps in, either my airbag inflator, the LiDAR enclosure, or that battery cell, if water vapor creeps in, the LiDAR could literally go blind. So if you've got humidity inside and it fogs up the lenses, it kind of clouds the vision, if you will. LiDAR is an emerging life safety component of autonomous vehicles. You can't have a vehicle that's got its vision system fogged up because of vapor ingress. So that's another thing that we're working on with customers, is keeping the water ingress out of these autonomous vehicle components like LiDAR.
Yeah, and I think it just kind of drives home the point of why leak detection is so important. Some of the largest or biggest stories in the automotive industry: battery fires, airbags exploding, AVs crashing into pedestrians. Leak detection can help solve a lot of those issues. So while a lot of people might not really think about it or know how important it really is an important thing to the industry. So it's great to sit down and be able to speak with you today, Thomas.
Well, good. It's good to speak with you also. Thanks for having me on the program.